Hi friends, this is Charan. Let me introduce myself. My name Charan KUMAR. Present I am working as an assistant professor. I am here to teach you guys on the topic engineering drawing. Which is helpful for both all the engineering graduates as well as for the polytechnic people. Right. So today I'll let you know about all the important topics that are present in engineering drawing. So let us see what are the topics present in this engineering drawing. Topics that we are going to discuss are: number 1 is conics, among which we have ellipse, and under ellipse we have two important methods. One is arc of circle method, and the next one is oblong method. Coming to topic number 2, it's scales. We are going to learn only about two important things. Number 1 is the diagonal scale, and the second one is vernier scale. And the third topic, the easiest topic among the entire engineering drawing topics, it's points. And the fourth one is lines. Fifth one, planes. And the sixth one is solids. Seventh one is isometric projections. And the last topic is holographic projections. We shall discuss one topic after the other. So at the beginning, let us move to the topic conics. Okay, so among conics we have two important things, and number 1 is ellipse. In ellipse, as I said, we are going to have two important methods. Number 1 is arc of circle method, and the next one is oblong method. Before moving into the methods, let us know something about ellipse. So generally the elliptical shapes are going to be in this format. This is an ellipse, and generally an ellipse has a larger axis. Two important axes it has. One is the larger one and another one is a shorter one. This the larger horizontal axis is the major axis, and this vertical smaller axis is the minor axis. So this is our major axis, and this is our minor axis. And we are going to have two fixed points, which are nothing but foci, focus 1 and focus 2, and a plural form is known as foci. In the questions you are going to see them as fixed points. So two fixed points we are going to have. The fixed points are going to lie on the major axis, F1 and F2. So these are the two fixed points. How we are going to attain these two fixed points, we shall learn in the next class. And let us move for the next one. Let us learn about arc of circle method. that is for the ellipse construction. Generally the questions are going to be, I'll show you a few things. See here guys, under Conics arc of circle method and oblong method, let us take the first question. We have the major axis of an ellipse is 150 mm long and the minor axis is 100 mm long. Find the foci, okay, F1 and F2, and draw the ellipse by arc of circle method. And in the same question he is asking us to draw a tangent to the ellipse at a point on it 25 mm above the major axis. So let us construct the curve. So we have the major axis of the ellipse is 150 mm and minor axis of the ellipse is equal to 100 mm long. So let us see. So here we have major axis of the ellipse 150 mm and minor axis 50 mm. So 10 mm is nothing but 1 centimeter guys, just remember. So I am taking the scale. Here is the one. So as I said, it's 150 mm. 150 mm is nothing but a 15 mm scale, 15 centimeter scale. Okay, I am going to take the center, that is 7.5. So here it is. Okay, now we shall draw the minor axis, which is about 100 mm, which is 100 mm. So 100 mm in the sense 5 mm to the top and 5 mm to the bottom. So this is our minor axis. So we finally got the major axis and the minor axis. Now we need to find the foci F1 and here and F2 over here. How to find the major foci on foci F1 and F2? So take, this is half of the major axis. Okay, this is completely, okay, 150 mm of major axis. Take half of the major axis. Okay, so half of the major axis is this part. Okay, or this part. Okay, take half of the major axis as radius and keep at one end of the minor axis and cut the arcs on the major axis on both the sides. Understood guys? Take half of the major axis and keep at one end of the minor axis and cut it on both the sides, so that we are going to get the foci F1 and F2. So this is F1 and this is going to be F2. So now this is the center of the ellipse, and let us consider the ends of the major axis as A and this end as B. So the distance from F1 to 0 has to be divided into some particular number of points. So let us take 3 points. You can take anywhere else of your own wish. I am not measuring any equal distances over here. So take any parts at anywhere without any equal measurements. Right. Now how to construct the curve? The first part, take A to 1 as radius. Okay, so take A to 1 as radius, fix this radius, and with F1 as center, cut the arcs on the top and as well as at the bottom. With the same radius, move here, keep it on F2 as center and cut the arcs. Now with A to 2 as radius, with F1 as center, cut the arcs at the top and cut the arcs at the bottom, and go to F2 as center, cut the arcs at here and arc at the bottom. Now with A to 3 as radius, F1 as center, cut the arcs at the top and an arc at the bottom. With the same radius, with F2 as center, let us cut the arcs at the top and as well as at the bottom. So we have taken A21, A22, A23 as radius. Now in the similar manner we have to take B21, B22, next B23. So the first part is B2 so B21 has radius. Okay guys, so B21 has radius. Now F2 as center, cut the previous arcs over here and here with the same radius, and F1 as center, cut the previous arcs here. Fine. Now with B22 as radius, now F2 as center, and let us cut the opposite arcs, and with the same radius, now with F1 as center, let us cut these two previous arcs. Fine. Now finally B2 3 as radius, F2 as center, let us cut the previous arcs, and now F1 as center, let us cut the opposite curves, this one, this one. Finally we got all the points P1, P2, P3. So now it's time to join all these points to get our curve. With a free hand I am joining all these points. So without any kind of error, we are going to get a very good fine curve. So this is the construction of ellipse, guys. Hope everyone understood. So now let us move for the arc of circle. After completing the arc of circle method, we shall learn about oblong method. Okay. So the same question with same as major axis is equal to, now we shall go with oblong method. Okay, in order to construct an ellipse, the same question we shall consider as the previous one, with major axis is equal to 150 and minor axis as 100 So according to the oblong method, let us take taking 15 150 that is 15 centimeters. I am taking the center at 7.5 as done before. Now let us take 5 centimeters upwards and 5 centimeters down. Okay, now what we shall do is that we need to construct a rectangle same as below. Finally we formed a rectangle. Okay, so what is the next process? Generally in geometry we do have the two lines. One is the x-axis and the other one is the y-axis. Here this is going to be the center and the points are going to be 1, 2, 3 and so on. 1, 2, 3 and so on. And here we are going to have -1, -2, -3, -1, -2, -3. So if this is the x-axis and this is the y-axis, we are going to have the center and the points in this manner. In the same manner, if we consider this as x-axis and this one as y-axis, and this is going to be our center, let us consider this as a center. Okay, here we need to divide the half of the major axis. This is a complete major axis, so this is going to be half of the major axis part, and this is our minor axis length. Okay, so we need to, this is our x-axis and now this is our y-axis. We need to divide the x-axis and the y-axis into equal number of parts. We need to divide this part and this part into equal number of parts, and the number of points on x-axis should be equal to the number of points on the y-axis. So I will tell you the easiest method to divide things into equal number of parts. So what am I going to do is that I wanted to get 3 points over here. That is, I wanted to divide this x-axis and y-axis into 4 parts. So 4 parts in the sense, sorry, 3 parts in the 4 parts in the sense I need 3 points. So for 3 points, So 4 parts, as it is for 4 parts. So keep it at 4. I am keeping the division at 4 center. Now I am going to mark at 3, 2, 1, 0, 5, 6, 7 and 8. So I kept equal points, okay, by keeping at 4, and I got the equal divisions. Now what we shall do is that the last point has to be touched, okay, has to be marked to the last end, last corner over here. Okay, so now if you have a drafter, fix the drafter for this point to the last corner. After fixing the drafter, slowly move the scale or the drafter to get the first point on y-axis, and slowly move the next one, and finally to the last one. So here you got equal number of divisions, that is 3 points. In the same manner, this is the last division. Join this to this part. Okay, now fix the drafter or the scale and parallelly move to the next point, so that you can get the first point on this one, and second point, and finally our third point. So finally we got the 3 points on y-axis and 3 points on x-axis, as we did 1, 2, 3 namings, 1, 2, 3 namings in this manner. So this is center 0, 1, 2, 3. These are the parts, and this is going to be 1, and this is going to be 2, and this is going to be 3. So these are the divisions we did so far. Now we have this as the minor axis end, and this is the another minor axis end. Now we have to join the points on the y-axis to the nearest minor axis end. So to this y-axis, the nearest minor axis end is this one. So join the y-axis point to the minor axis end. So let us take from 1 to the minor axis end, this one. Let us join these parts. Now move to the other end of the minor axis point. So minor axis end is other end is this one. Now join the draw lines joining the x-axis points and touching the line number 1, and in the same manner with line passing through the point 2 and extend it touching to the line number 2, and in a similar manner point number 3 touching the line number 3. So this is how we got the required points. Point number 1 P1, point number 2 P2, point number 3 P3. So we can finally get the curve by joining these points. So join all these points with free hand. See guys, we got 1/4 of the curve. In the same manner, okay, we have to perform the same steps in block 2, block 3 and block 4. Okay, so here we are going to consider this one as the y-axis, and this is going to be our x-axis. Okay, so we need to divide this. So this is going to be center 1, 2, 3, 1, 2, 3. Divide these parts, and then this is going to be y-axis. The nearest end to the y-axis is this is the minor axis end point. Now join these points to the y-axis. Now go to the other end of the minor axis, this one. Join the x-axis point and extend them. Join the x-axis point and extend them to the respective lines. Okay, so this is a long procedure, so better we shall go to a shortcut method where we can do things very fast. So what am I going to do is that, okay, fix the drafter or the scale to the measure axis perfectly, then move to one point of the other point. So this is the first one. Extend the lines, come to the next one, so what we need to do is that measure these distances, okay, distance from the point to the minor axis, and name the same distance over here, and in the same manner measure this distance and mention the curve, and measure this distance, okay, and finally cut the point. So finally we got all the required points over here. So we can draw the curve with free hand. Okay, so let us extend the same procedure even for the next one. Now keep the drafter of the scale fixed to the minor axis and let us move forward and drop this one, drop these lines downwards. Okay, now we shall measure these distances. So we got the points over here too, and in the same manner we shall drop these points downwards. Measure this distance. So finally we got all the required points, guys. So let us join them with free hand. So finally we are done with the construction of the ellipse by using oblong method as well as with the arc of circle method. Now we shall draw the tangent as we have seen in the previous question. Let us see the question once again. So we see the question over here. So major axis 150 mm, minor axis is 100 mm long, and here we had a question to draw a tangent to the ellipse at a point on it at 25 mm above from the major axis. So we need to draw the tangent, and even let us draw the normal also, okay, which is at a 25 mm above from the major axis. So first we shall see the method. Okay, first we shall see the method, then we shall discuss the next topic. So if we have construction of tangent and normal to an ellipse. So what is the actual method? If we are done with the construction of an ellipse using either arc of circle method or else oblong method, okay, so it is going to have the major axis in this manner, and this is going to have the minor axis in this way. Okay, we need to get the focus points F1 and F2 on the major axis. So we know the procedure that take half of the major axis as radius and one end of the minor axis as the center, and cut the arcs over here, cut an arc over here and cut an arc over here. So that is the procedure in which we are going to get the foci. So F1 over here and F2 over here. Then we need to take a point on the curve anywhere, okay, anywhere on the curve according to the requirements. So let us consider the point is P is present over here. Okay, so immediately what we need to do is that, okay, join the point to the focus 1 and focus 2. Okay, so join this point P to focus 1 and focus 2. Here you are going to have an angle known as theta. We need to bisect the angle into two parts. Okay, half of the angle we need to take. So for which the easiest process is use a protractor and use a protractor and measure the angle over here. Here we have 100 and 108 is the angle we have. Okay, so 108 in the sense half of 108 is nothing but 54. So 50, this is going to be 54. So 54 the point is. So join the point P to the point that we got. So it is going to give you one line which is going to be a line that is cutting the arc. So the line that is cutting the arc is known as the normal. So this is our normal to the curve. So the normal cuts this particular angle into half. So that is, it is going to be theta by 2, and this angle is going to be theta by 2. Okay, so bisection of angle is going to be in this way. Generally normal and tangent are going to be at perpendicular to each other, that is they are going to be at 90 degrees. So let us at this point P keep the protractor, and at 90 degrees keep a point and join this point P to the point that we have kept. So now, and we got the required line known as the tangent. So tangent is the line that touches the curve. So this is our tangent and this is going to be our normal. Okay, so as per the previous question, we had to draw a normal and a tangent to this curve. Okay, we are required to draw a tangent and normal to this curve, which is at a distance of 25 mm from major axis. Okay, so 25 mm from major axis. So from 25 mm from major axis we need to keep a point on the curve, then we can draw the tangent. So let us take, so this is going to be 25 mm, so 2.5 centimeters. So what am I going to do is that I am going to move this scale or the drafter in this manner such that I can get the point P on the curve. So I got a point P on the curve at this particular respective point. This is the point where I got point P. Okay, so this is point P. So what we shall do is that join point P to the foci focus F1 to F2. So here we get certain angle theta. So let us measure what is the angle present over there. I am keeping the protractor here. Okay, you guys can clearly see that this is 64 degrees I got. So half of 64 is going to be 32 degrees. So let us take 30 and this is going to be 32. So at 32 I kept a point. Okay, so this is 32 degrees point and I am going to draw the line, required line. So this is going to be our normal. Okay, the line that we got now is going to be our normal, and the construction of tangent is going to be, let us keep the protractor at 90 degrees to the normal. Okay, at point P, and I am keeping at 90 degrees, that is over here. So now let us join point P. Let us join point P to this one. So we are going to get a new line. So this is our tangent and normal construction. So remember guys, this is tangent and this is normal. So every time a normal cuts the curve and a tangent just touches the curve. So thank you for watching this video. Hope you understood how the construction of an ellipse using arc of circle method and oblong method, and even the construction of a tangent and normal to the particular curve. Thank you so much.